over a couple things here. We have a couple of rules when we're dealing with exponents that can be negative or 0. And what I want you to do here is we're going to just take this table and we're going to expand it out. So 2 times 2 times 2 times 2. So that's the expanded. Remember, standard is when we're putting it into, or just evaluating it. So let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, right? All right, then let's expand this one out. 2 times 2 is 4, times 2 is 8. Then we're going to have 2 times 2 is 4, and then 1, 2 will be 2. Now, I want you to stop for a second. I want you to see if you see a pattern going on here. So we're going from 16 to 8 to 4 to 2. So you'll notice that we're going down, or we're actually dividing each of these by 2, right? Because 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2. Now 2 divided by 2 is 1. So that is what we call the 0 power. So anything to the 0 power looks like it's going to be 1. Now let's look if we get into negatives, okay? So if we get into let's continue the pattern and then we'll see what happens with negatives, okay? So if we continue the pattern and divide 1 by 2, well, 1 divided by 2, wouldn't that just be a half, right? Okay. Now, if we divide 1/2 by 2, if you go back and remember your old rules, we had keep, change, flip. That would be 1/4, right? Divide that by 2. You're going to do keep, change, flip again. That would be 1/8. And then the last one would be 1/16. Now, I want you to look at the expanded version, and I think we're going to come up with our negative exponent rule right here. All right, so there's 1, 2 on the bottom right. There's 2 2's on the bottom. There's 3 2's on the bottom, and the last one there are 4 2's on the bottom. All right. Now, instead of writing 2 times 2, couldn't you just write 1 to the 2nd power? Make it a little easier, right? Or instead of writing 3 2's, you could put 1 and 2 to the 3rd power. And the last one could just be 1, 2 to the 4th power. So now, if you look at all the negative exponents, right, you'll notice all of them turned into fractions. So if I want to get rid of a negative exponent, because I'm not going to want you to keep anything negative as an exponent, you would just put it on the bottom. Let's look at one more example I have here. I have 2 of them. We'll just do one of them. Let me flip it over so you can see it here. All right. Let's look at the 3's. Okay. All right, so again, expanded form would just mean 4 3s, right? Standard, well, 3 times 3 is 9. And then another 3 times 3 is 9. So 9 times 9 is 81. Now let's do the next one. 3 3s. Well, 3 times 3 is 9. Times 3 is 27. 3 times 3 is 9. And then 1 3 would be 3. And guess now, look at the pattern is now we're dividing by 3, right? The base. So, anything to the 0 power, well, 3 divided by 3 is what, guys? 1. Okay. 1 divided by 3 is 1/3. 1/3 divided by 3 is 1/9. Okay. And then the next one would be what? Catching on 1/27th. And then 181. If we did the expanded version, right? Well, that would be 3 times 3 times 3, or we'll do, whoop, I'm sorry, that would only be 3. Let's go back. I put too many 3's there, right? It's only 2 of them. 3 times 3 is 9, or 3 squared. That would be 3 3's, or 3/3. That would be 4 3's, or to the 4th, right? So again, anytime we have a negative exponent, it becomes a fraction. So just a couple of examples here. So if I had 4 to the negative 6, and I wanted to get rid of that, I would make that a fraction, right? If I had 4 to the 0 power, that's going to be 1. Anything to the 0 power is 1. All right. So those are all our exponent rules.